Hi everyone, let's solve merge k sorted list. You are given an array of k linked lists. Each linked list is sorted in ascending order. Merge all the linked lists into one sorted linked list and return it. So this problem is similar to merge two sorted lists, which we have solved in one of the previous videos. It is an extension of it. So if you haven't watched that video, please watch it before this. And so this is the example given. There are three lists in this case, list 1, list 2, list 3, and the output is the sorted order of that particular list. So this is the example. Now let's try to understand a theory first of something important before we take this particular example. So let's say I have these are the lists. Let's say I'm going to merge these lists in linear. It is going to take me so basically 1 to 6. So if you see, the number of steps are 1, 2, 3, 4, 5, and k is 6 here. So it is taking k minus 1 into n. N is number of nodes across all the lists and k is number of lists. So it is taking k minus 1 into n. Let's try to optimize this first. Let's say 1, 2, 3, 4, 5 and 6. So in this case, if I merge these, let me take just one more example here for better understanding. So this will be just 7 and this entire list will be 5, 6, 7 and this will be so on 7. This is the final list. So let me count the number of steps taken here. 2, 3. There are close to 8. Log 8 base 2 is nothing but basically we got 7. There are 7. So it is log base 7 into n. N is number of lists. So this is the amount of time which it takes for us to reach the final elements. N is to iterate over all the elements, but number of times we are merging the list will be log n. So this is much faster than merging one list with the other and then using the merged list with the other one. So this step is faster. I have explained how it is faster. So now in this case, what are we going to do is, like, let's say if the list is of length some k, we are going to merge two lists every time and we are going to push it to our original list, and then we are going to continue the process until we get the final list. How do we know if we got the final list or not? When our list contains only of length, if the list dot length is equal to 1, that means that we have reached our final list, right? Otherwise we just keep continuing our process of finish step 1, then generate list, and then again continue, so on. So now let's try to code it up. The same example which we are doing here, we are choosing two lists at a time and merging, and storing that in a list, and then again continuing the same process unless we get the length is equals to 1. So as long as the list length is greater than 1, we just keep iterating and get the result. So, and also one more thing here, we have already, as I mentioned, we have seen how to merge two sorted linked list. So you can follow that. I'll any which ways write the code. So let's say for example, if list.length is equals to 0, then we have nothing to process. We can just return null from here. If that is not the case, while list.length is greater than 1, which we just discussed, what we have to do, we have to create merged list, which is an array of head pointers. And now for I plus equal to 2, so that means we will have two lists. Let me have L1 as lists of I, and L2 can be present or not present. We have to check because we are moving two pointers, two indexes at a time. So it might happen that I plus 1 will not be available. If it is available only, then list of I plus 1, else it will be null. As we seen in this example also, there is no 8, but we still could take the number here. So in this case, this is done. Now I have to get the merged list. Merged list is equals to merge list, and I will pass L1 and L2. I will get a merged list, which I'll write now, and then I have to push merged lists dot push into push of merged list. Now what I have to do is I have to assign my merged list to my list. This is how we keep iterating and we keep checking. Now let us also write merge list L1 and L2. If we do not have L1, just return L2. If we do not have L2, return L1. If both of them are present, L1 and L2, we have to create our dummy node, list node of 0, and then we need one more pointer to just track. So if L1 dot value is less than or equal to L2 dot val, then head dot next is equals to L1, L1 dot next, L1 is equals to L1 dot next, and head equal to head dot next. Else it would be head dot next equal to L2, L2 equal to L2 dot next, head equal to head dot next. And it might also happen that there will be some remaining elements. If L1, head dot next equal to L1, if L2, then head dot next equal to L2. So this is it. Now we have to return dummy dot next. So yes, and in this case also, once it is done, we have to return list of 0, because list always contains the head of a linked list. So list of 0 will have the link head of the linked list, which is merged finally. So let's try to run it up. Yes, it is accepted. Let me submit it. Yes, I hope the solution is clear. Now the time complexity of the solution is big O of log k into n, as we discussed. because we have to iterate over all the elements. Number of elements in all the list is n, and k is number of list. So let's go to the description here, and so k is okay, n is not present here, so we can just consider that as n. And space complexity of this solution will be big O of k, because in the list here, in the merged list, I am storing head of each list. After merging there are k heads, so that is k time. So this is the time and space complexity of the solution. I hope the solution is clear. Thank you.